Okay, so we are 2 minutes past 4, so I guess we need to start. Um, First, let me do a quick self-introduction first. Hello to everyone. Thanks for joining this event. My name is Nancy. I'm a software engineer at Meta, and I focus on ads ranking area. During this talk, we will give a quick introduction to ads ranking, and we will go through several commonly used algorithms to conduct recommendations. And this talk will take around 30 minutes. There will be no Q&A session for this talk because of the NDA agreement I have with the company. But please feel free to send me emails or messages if you have any question. I am more than happy to answer as much as I can. Okay, let's get started. So here's a picture shown for the newsfeed. It is very common to see this whenever we open a social media platform. And we usually see some ads inserted into the newsfeed. And those ads are typically highly relevant to our interest and even related to our recent activities on that platform. Since users' interests change over time, it is critical to instantly identify their expectations in order to present the most relevant offers. Ads that are unable to adapt to users' current orientations could result in unnecessary costs for the company when promoting a product or service. And to avoid this, marketing researchers have turned to marketing efforts to present the most appropriate ad possible by analyzing and predicting user expectations. And all of this is made possible by recommendation algorithms. They are intended to keep users on the website or the app or any platform for as long as possible by displaying relevant content and advertisements. As a result, the user is prevented from encountering irrelevant content. Content is delivered to the targeted audience, and marketing strategies become more effective. This solution is based on machine learning, which implies that algorithms learn how to carry out tasks under various levels of human oversight. They are written by software engineers who employ methods of machine learning, and they manage multiple tasks that would be difficult for humans to complete at the same time. Machine learning models predict a specific person's likelihood of taking the advertiser's desired action based on the business objective the advertiser selected for their ad. For example, increasing visits to their website or driving purchases to determine the estimated action rate. To accomplish this, models take into account that person's behavior on and off social media, as well as other factors such as ad content, time of the day, and interactions between people and ads. Let's take a closer look at the models that will be used for recommendation system. So the most common method for developing ranking models is to predict the likelihood that a user will make a purchase after seeing an ad. The input is a collection of various features that can be used to describe the user and the ad, and the output is just the probability that the user will make a purchase. So the recommendation system can sort ads based on the relevance to prioritize which content a user sees first, based on the likelihood that they will interact with it. So for example, the ads that appear first in the Instagram feed or stories are determined by ranking algorithms based on data about what users have previously viewed, purchased, or done. Machine learning models predict a specific person's likelihood of taking the advertiser's desired action based on different business objectives. Um, in the end, the ad with the highest likelihood of purchase will be displayed in the user's newsfeed. And to predict the items that the user might be interested in, several algorithms are commonly used. Let's look at some of them more closely. So let's first discuss about the collaborative filtering. Collaborative filtering, it's a very simple and intuitive method to do recommendations. There are two different types of collaborative filtering, user-based CF and item-based CF. Let's start with user-based CF. The assumption for user-based CF is that similar users will like or dislike similar things. Let's say, let's say we have a table where each row indicates a user and each column indicates an item. And every element in the table means how interested the user is in the item. And this could be extracted from past user behaviors. For example, how much the user has spent with this ad, or what is the score the user gave to the bought item. Thus, each row in the table could represent a user with a vector, where each element is a kind of score that the user has given for the candidate. And with the help of user vectors for any given user in the table, we should be able to find a list of most similar users. To do this, we just need to compute cosine similarities between the target user and every single remaining user vectors, and to keep the top k users based on cosine similarities. And for a pool of items that the target user has never interacted with, the system can use the similarity weighted average score for this item derived from similar users and use this score as the predicted score for the target user, which is just the formula shown here on the top left corner. The ranking system can give all the candidates with this mechanism and recommend the items with the scores from top to bottom. And item-based CF, it's having a quite similar idea as user-based CF. Instead of finding similar users, item-based CF tries to find items that are similar to the items user have previously shown interest to. Let's say we still have the same table here, where each row is a user and each column is an item. Then every column vector represents an item. And for target user, we can easily read a list of items the user has interacted with before. And then for an item that a target user has never interacted with, the system can compute a similarity weighted score based on the item and the list of user previously interacted items. The system can then rank all the unknown items based on this weighted score and to do the recommendation. So collaborative filtering, it's a very straightforward, intuitive, and easy to implement ranking algorithms. However, its drawbacks are also very obvious. So the first thing is that the matrix we generated here, it's based on user behaviors, which could be really sparse, since usually a user only interacts with a very small subset of candidates. And this affects similarity computation and then recommendation results. And the second issue is that collaborative filtering only leverages user past behaviors. However, there are still a lot of other features that could be very valuable when conducting recommendations. So for example, the user set features, such as the age or the gender, and also item set features like category, the product price, and maybe the ad descriptions, and also context features, for example, um, the time of the user and the location of the user and the day of the week, etc. And to compensate this, here comes with the logistic regression. Logistic regression allows us to use all different kinds of features to boost our recommendation result. Compared to collaborative filtering, which recommends based on either user similarity or item similarity, logistic regression treats recommendation as a binary classification by predicting what is the probability that a user will click or view or purchase an item. The recommendation list is then generated based on the probabilities from different items. And let's have a deeper look at the structure of the logistic regression. So, what is logistic regression exactly? Logistic regression is just a normalized version of the weighted summation of all the input features. Here, let's discuss more details on what could be input features, how can we get the weights, and what does the normalization mean here. So first, the input features. As we mentioned earlier, we can have user set features, item set features, and context features. And usually we should also have features that can describe user past behaviors. For example, a list of features that covers the IDs of the last 10 items a user has bought. And usually these kind of features are very important to recommendation result because they capture the user's interest directly. And all these features are concatenated together to get a very long list of features. And then we do a dot product between this list of features and a list of weights. So here comes the second question. How can we know the weights? Well, this is a very typical machine learning problem. So here, every training data point, it's a feature vector and label pair, where the feature vector is just the list of features we mentioned earlier, and the label here is a binary label, which indicates whether the user has interacted with the item or not. Since it is a binary classification, cross entropy is then used to measure the gap between model predictions and the ground truth labels. Mm, the weights will be updated using gradient descent to minimize the loss here. And for the normalization, logistic regression adds a sigmoid function on top of the weighted sum to make sure that the output is always between 0 and 1. So in other words, by having this sigmoid function, we can make sure that the output is always a valid probability because we are trying to model whether the user, how likely the user will click or purchase the ad. Logistic regression is a very lightweighted model that is easy to train. It doesn't require a lot of infra resources. And given the simple structure of logistic regression, it is also easy for us to understand the feature importance directly from the features in the logistic regression model. So, for example, if a feature has 0 as weight, then this means that the recommendation result won't be affected by this feature at all. However, logistic regression doesn't have feature cross. So, for example, we have age as a feature and also gender as a feature, but there's no feature for age cross gender. The expressivity is quite limited for logistic regression. And to resolve this, factorization machine is put forward. So to increase the model capacity, the factorization machine comes out, where the second order feature class it's introduced to the model automatically. Let's have a deeper look at the formula of the factorization machine. So we can actually consider the factorization machine as an extension to logistic regression. So the key idea in the factorization machine is that for each feature, the model will learn a latent vector for it. So in the formula here, like XP and SQ represent two different features, and VP and VQ are the latent vectors learned for these two features. And for every pair of features, their feature values are multiplied together and then multiplied with the dot product of their latent vectors. And then the final multiplication results from each pair are summed together. And this sum in the end encodes the second order information we need. And if we just ignore the last item here, and if we focus on the first two, it is just the logistic regression. So this is the reason why we are saying like that the factorization machine is just an extension to logistic regression by introducing second order feature cross automatically. And the second order sum is added as an extra term to logistic regression weighted summation, and the final summation will be fed into the sigmoid function to get the final result to make sure that the probability is always between 0 and 1. And all the previously mentioned models are kind of traditional machine learning algorithms that can be used for recommendation. And since deep learning has become more and more powerful in recent years, it's quite common to have deep neural networks as the recommendation models. And one of the most famous deep learning recommendation models is called Wide and Deep, which was put forward by Google in 2016. So wide and deep balances both memorization, which is through this wide part, and also generalization, which is through this deep part. Wide part is just uh, the input from raw features that could enforce the model to memorize the certain pattern in the training data. And deep part, it's a multi-layer neural network where a high-order feature cross is conducted and high-level abstract informations are extracted. And results from wide part and deep part are combined through logistic regression, and the output will base on both of them, which in the end bring memorization and generalization to the model at the same time. And the drawback for this framework is also obvious. There's no second order feature cross in this wide and deep framework, and as a result, the expressivity for this wide and deep framework is also very limited. And to resolve this, here comes another well-known ranking model, which is DeepFM. And this is evolved from wide and deep model architecture. As we can see from this picture, in DeepFM, the factorization machine here, it's used to replace the wide part in the wide and deep framework. As we discussed earlier, the advantage of factorization machine is that it supports automatic second order feature cross. By introducing FM to the wide and deep framework, DeepFM boosts performance through leveraging second order feature cross, and the output from FM layer and deep part are concatenated together and fed into a logistic regression to give the final prediction. So to summarize what has been discussed so far, Recommendation systems are one of the most efficient ways for social media platforms to move users through the buyer's journey and thus generate more revenue. The amount of revenue that ads can generate is directly related to the number of purchases that take place in the end. This is where a machine learning powered recommendation model can help by predicting the probability that a user will click or view or purchase an item when showing an ad. The model predicts the most relevant ads in the user's feed by leveraging various user set features, item set features, context features, and even user item interaction features. But the ultimate goal is the same, a purchase on the advertiser's website or within the app. As for the particular ranking algorithms, collaborative filtering it's a simple and straightforward one, where recommendations uh, it's based on similarity users or items. However, to use as many features as possible, logistic regression comes out to enable automated second order feature cross. The factorization machine is put forward on top of logistic regression. And to further improve the model capacity, the recommendation model moves to deep neural networks. And in order to balance model memorization and generalization, wide and deep has become popular. And to compensate for the second order feature cross, deep FM is put forward later on top of wide and deep to introduce feature cross. So in other words, leveraging all these algorithms can help provide the most relevant advertisement offers for users, raising their satisfaction with the platform and increasing the revenue social media platforms receive through advertisements. And this is all the content I have today. And thanks everyone for joining. And if you have any question, please email me or message me through the email address shown here. I'm happy to answer them. That's all for today. And thanks again, everyone. And hope everyone enjoy the rest of the day. Thanks.